Okay, this next problem is what we call our bow beam bearings, and with these we're solving for our distance off of an object. So these type of problems, you're trying to figure out how far off of an object you are, and in the questions they're going to say you first sight this light at this bearing, and then X amount of time later you sight it again at this bearing. What is your distance off the light? Now, this type of problem has a very distinctive part of the question that is almost a telltale on how to figure it out. So in this type of question, they're going to be giving you bearings, but they are relative bearings. Okay, these relative bearings uh, are going to double. And when we do this, we make an isosceles triangle, and what ends up happening is the distance that we travel is the distance that we are off of the light. So this problem just ends up being a time speed distance type of problem. So here we are cruising along. It's going to say you sight this light at a bearing of either 045 or 315 degrees relative. This type of bow beam bearings works on a lot of different relative bearings, but we're only going to be using the 45 and 315, and then we'll see what the double is here. So it's saying at 8 o'clock we're at 6 knots, and we sight this light at that bearing. We're going to take a second bearing when we hit the doubling point, so 090 or 270 degrees relative. All right, so how far did we travel in that time? Well, 30 minutes, 6 knots, we traveled 3 nautical miles. And because that leg of the triangle is the same distance as this leg of the triangle, that's how far off the light we are. And that's how we solve this problem for our bow beam bearings.